In this video, we continue our introduction to multiple regression by taking a look at R squared, and the ANOVA F-test. Our goal is to see the close parallels between how we analyze and interpret these measures in multiple regression and how we previously analyzed and interpreted these measures in simple regression with a single predictor. First, let's jump back to the model summary table. Now you'll notice I'm still fading out part of the output for now in order to avoid some confusion. But more importantly, you may notice that the R and R squared are written as capital R's, where in simple regression and correlation it was a lowercase r. Now that's not a mistake. R's a little different in multiple regression. Now R squared is still the variance in the outcome that was accounted for or related to our regression model, but now it's a set of variables, not just one variable. But we'll interpret and discuss it exactly the same way. And thinking of Cohen's small, medium, and large effects, his rule of thumb for R squared is that a 0.02 reflects a small effect, a 0.13 or an R squared of 0.13, accounting for 13% of the outcome variance, is a medium effect, and an R squared of 0.26 or our predictor set of variables accounts for 26% of the variance, is a large effect. But it still really depends on the data and the question. What's a small effect in one situation may be a large effect in another situation. So these rules of thumb should be used and interpreted with caution. Now, remember, in simple regression, the R, our lowercase r, ranged from -1 to +1 and indicated the strength and the direction of the association between a single predictor and the outcome. But with multiple predictors, R, now our capital R, can't indicate the direction of the association because some predictors may have a positive association and other predictors may have a negative association. So in multiple regression, the multiple R, uppercase R, only indicates the strength of the association between a set of predictors and the outcome. And whereas in simple regression, R ranged from -1 to +1, in multiple regression, the multiple R only ranges from 0 to +1. Again, 0 to +1 because it doesn't indicate the direction of the effect, just the strength of the association of the set of predictors. Now, let's dig into this a little more. In simple regression, we saw that the R squared was equal to the sum of squares regression divided by the total sum of squares, and that's mathematically equivalent to the proportion of the total variance in the outcome that's related to our single predictor in simple regression. That's still true in multiple regression. In multiple regression, R squared is, you guessed it, the sum of squares regression divided by the total sum of squares. It's exactly the same. Also in simple regression, we saw that the F statistic was equal to the sum of squares regression divided by the degrees of freedom regression over the sum of squares residual divided by the degrees of freedom residual. We saw that this could also be expressed as the R squared divided by K, the number of predictor variables, over 1 minus R squared divided by N minus K minus 1. And because in simple regression, K, the number of predictor variables, is equal to 1, this reduces to R squared over 1 minus R squared divided by N minus 2. Well, in multiple regression, the F statistic is,
wait for it,
exactly the same. It's the sum of squares regression divided by the degrees of freedom regression over the sum of squares residual divided by the degrees of freedom residual. Furthermore, in multiple regression, the F can still be expressed in terms of the variance accounted for. It just uses the multiple R squared instead of the Pearson R squared. This is essentially exactly the same as in simple regression, except in simple regression, K, the number of predictors, was, by definition, always equal to 1, and in multiple regression, K can be 2 or 3 or 4 or more. Okay? This is a good point to wrap up this video. How we interpret and test R squared in multiple regression really is the same as how we interpret and test R squared in simple regression. We're just accounting for more variance with more variables in multiple regression. In our next video, we'll discuss testing our regression coefficients in multiple regression. Okay? Take care. Bye-bye.